The broadcast is now starting. All attendees are in listen-only mode.
Hi, everyone. Thank you for joining. You are all on mute, but I do want to make sure you all can hear me first. So if you can raise your hand in the panel on the side and let me know that you can all hear me before I hand it over to Colin. Awesome. Thanks, guys. Okay, so if y'all have any questions, please ask them in the panel below and we will answer them afterwards. Anything that we cannot get to, we will post it in our blog and answer all of those. And as you know, this will be posted 48 hours after this time, and it will be available on our Percona website. So I'm going to go ahead and handle it over to Colin, and we can get started.
Hello, thank you. Good morning, afternoon, or evening to everybody. I'm Colin Charles, and I'm here to talk to you about best practices for MySQL high availability. I work at the CTO office as a chief evangelist for Percona, and I also know a little bit about MariaDB server, being on the founding team of that. So it's very well worth noting that Linux distributions obviously are shipping things in varying formats. If you ask for MySQL today, you may be getting MariaDB. So we obviously have MySQL 5.7 and Percona Server 5.7 as the most current releases of MySQL. And a lot of what I want to speak about is about 5.7 and obviously because that is the latest, it's been around for more than a year and it's good. MariaDB will also get a little bit of coverage as well because it is different from 10.0, 10.1, and obviously 10.2. So your choices for high availability are also largely defined by the kind of server that you end up using. So what is high availability? On the top left-hand corner, I talk about throughput, which is usually measured in transactions per second, TPS. We also talk about latency, which is response time measured in percentiles. So, that's the performance and scalability part of HA. But HA also means durability, and the durability is the D in ACID. Basically, the D durability stands for the fact that you never ever lose commit data. And there are multiple ways for you not to do this. You have replicas, snapshots, point-in-time recoveries, backups. But probably one of the most important thing is for you to also be ensuring that you're, syncing the binary log and also flushing the transaction log. And then if we go down a little bit, high availability is also about obviously replication, which provides redundancy. And it is also about clustering, where again don't have a single point of failure with either replication or clustering. But the clustering portion is where you think about monitoring, recovery, failure. You always think about the time the service is down, and you tend to measure this, in obviously seconds, and if you have multiple machines in machine hours and so forth. When I say clustering, I'm obviously not referring to, say, MySQL NDB cluster. I'm referring to clustering as a solution or overall. And this is, not one of those alphabet soup slides. It's a logo slide, basically telling you the various solutions out there which actually have logos, and there are a lot of them, obviously. So when we think about high availability, we also definitely think about uptime, and uptime is translated to the level of availability. And it is very fashionable to say you are, up five with up to 5 nines of uptime. But 5 nines of uptime also means about 5.25 minutes of downtime every for the server or the service. And you basically ask yourself, what does it cost you to be down every second or every minute? And then you start thinking about how much high availability you need to have. If you can afford, we've heard people say that, they've gone down even for 2 days while they migrate from one system to another. That obviously basically means you don't really have a very important service running and you don't mind the downtime, and HA is not so important for you. And we've seen sites like Pingdom basically publish statistics saying that the average site hovers around 99.6% of uptime, and only a fraction give you past even 3 nines of uptime. So a lot of sites go down for about 8 hours a year, and Pingdom can tell you this because lots of people subscribe to them. So we also have to estimate levels of availability based on solutions that are available out there. And as I said, if you deal with downtime at scale, you measure in thousands of hours as well. And failures don't even really trigger operations at scale because the replicated copy of data is being served just fine. When you have simple MySQL replication, you're looking at, at least 3 nines uptime. This improves tremendously when you start using semi-synchronous replication and a failover framework. Now, if you use something like master-master replication with a framework like MMM, which we do not recommend you to use nowadays in production, you get 99.9% uptime. Uh, More interestingly, we go down the stack and we look at things like DRBD, MHA, and tungsten replicator, all of which promise about 99.9% uptime, but you can get definitely higher uptime if you configure MHA or things like orchestrator tied in with it, and you should get even better uptime and availability. And then there's of course NDB cluster and Galera cluster, which we package as Percona HDB cluster, and that gives you 5 nines uptimes. And this will also include group replication from MySQL, largely because it gets away from the idea of having a master and a slave, where all nodes tend to be equal or nodes tend to be sharded across nodes, like in the case of NDB cluster. HA is all about redundancy. I mean, we think about it from RAID. We always have RAID in servers. You have multiple disks. You also cluster, so things always work. In terms of power, you always have redundant power supplies. Very commonly nowadays, in a geographical sense, you have more than one data center because sometimes data centers go offline for various reasons. And I have multiple anecdotes about this as well. And it's also obviously redundant in the form of biology. You tend to have two kidneys, for example. Durability. Durability is basically asking the question: is the data actually written to disk in a durable fashion? Is it written in order? Um, and this is of course quite important. You ask, are you calling fsync at each and every commit? Now, when you call fsync at each and every commit, you actually have a lot of overhead, and this takes away performance. But this is why we have what is known as group commit in the binary log, which will prevent you from having to call fsync at each and every commit. It groups the commits, and this has been available since MySQL 5.6 and MariaDB 5.3 onwards. But the algorithms are obviously different, but the intention is similar. And when you have a durable database, you also write it in a transactional way to guarantee ACID as well. So the atomicity, crash safety, and the integrity is also very important. HA is definitely harder for databases because you're not only caring about the data and the hardware resources. Data also needs to be redundant, and this is constantly changing data, so you have to be uninterrupted. Again, measured by percentiles. There is one other way to do HA, which is redundancy through client-side XA transactions. And this is where the client will write to two independent but identical databases with no replication anywhere. This may have been a good solution when you have databases without replication or replication you could trust. But really, you probably don't do this because you can get a lot of out-of-sync databases fairly quickly. And of course, this is not to be confused with server-side XA transactions, which are okay in general, and you can see them when you take a look at MySQL binlog. But of course, this that doesn't work on something like Galera cluster, for example. So this is InnoDB recovery time, and they say the larger your log files, the longer the recovery times. And at one stage, we at Percona server also included InnoDB recovery stats, but we've removed it since, and that's because paradigms change. So, if you look back about 10 years ago, Wikipedia would report that it took them about 40 minutes for InnoDB recovery with about 256 megs of logs. And then sometimes it would take 5 to 10 minutes, sometimes it would take hours. And that's because log recovery involves, finding checkpoint time due to fuzzy checkpointing, and then the log sequence number. You scan the log files from the last checkpoint, see if it's already applied to pages. If not, you perform operation in the log applying the change to the buffer pool. So lots of things like data locality, size of logs, buffer pool size, dirty buffers during crash all play a role. But you don't need to care so much about recovery time today because, as I said, paradigms change, which is why, again, we remove things like InnoDB recovery stats. When InnoDB crashes, you have replicas, and you don't really care about the recovery time anymore because you've just spun up other instances. There is also this other option of redundancy through shared storage. This one requires specialist hardware, typically like a SAN. It also has failover time, it's not instant. And this isn't really a scale out solution. This is the scale up versus scale out argument. And we don't want to talk about redundancy to shared storage naturally. There's also redundancy to disk replication. And this one is most commonly done by DRBD, which is RAID over Ethernet. It's fully synchronous. You have to use, obviously, only InnoDB, a transactional storage engine. And the second set of data is inaccessible for use. So because the passive server acts as a hot standby. But this is not very efficient because you've got hardware sitting in a rack doing absolutely nothing. Now, the only possible reasons you'd want to do this, and also the fact that you get a performance hit by using DRBD, is when I already used to a SAN, it's good. And if you believe that you really can't lose a transaction and longer failover is tolerated, but the really can't lose a transaction can also be achieved via using something like semi-synchronous replication. So this is probably not the solution going forward, for generally speaking. Then there's, of course, redundancy through MySQL replication, where there's MySQL's various ways of replication, the asynchronous, semi-synchronous, fully synchronous. There's also Tungsten Replicator, which has gone through multiple lives and is still around outside of its current VMware. There's Galera Cluster, which you can get several subproducts, that being Percona XDB cluster, MariaDB Galera cluster. There's also NDB cluster. Naturally, the storage requirements are obviously multiplied, but the potential for scaling out and powering your site is humongous. So MySQL replication is statement-based generally, but row-based became available in 5.1 and became the default in 5.7. This is an important change, right? Knowing that you've gone from statement-based replication to row-based replication as the default. And there's also mixed mode replication, where statement is used normally, but the row-based is used for these unsafe statements, where you have, say, a server variable used in a statement and so forth. Now, there's no one replication method that is better than the other, but of course, the default row-based replication now is generally what we would recommend you to obviously use. So replication is obviously asynchronous by default. This means that when the master writes events to the bit log, it doesn't know whether or not a slave has retrieved and processed them. So with asynchronous replication, if the master crashes, transactions that it has committed might not have been transmitted to any slave. There is also a semi-synchronous plugin in 5.5, and fully synchronous replication is it's not part of standard MySQL replication. So in the case of Percona Server 5.7, you either download Percona Server 5.7 for MySQL or Percona XDB cluster. Percona XDB cluster does have fully synchronous replication. The only one server out there that has fully synchronous replication built in is MariaDB Server 10.1, where they've merged all of the MariaDB Galera cluster code and made it one big download. So you can either choose between async, semi-sync, or the WSRep write set replication plugin. And the choice is obviously yours. There's also a whole bunch of logs that you need to think about. The bin log, or the binary log, is where events that describe your database changes are kept. Then there's also the relay log. Nowadays, 5.6 and greater, you also see the master info log with status and configuration information for slaves connection to the master, as well as the relay log info log, where the execution point in slaves relay log. The binary log is now crash safe if you use a modern version of MySQL greater than 5.6 or MariaDB 5.5 and greater as well. So this means it is being stored in DB tables as well. Semi-synchronous replication is where you get a thread that performs a transaction commit on the master that blocks after the commit is done and waits until at least one semi-synchronous slave acknowledges that it has received all events for the transaction or until a timeout occurs. So semi-sync capable slave is definitely the way to go. And there's a fairly old but gold blog post from Yoshinori Matsunobu that tells you that at Facebook, they run semi-sync at scale. And of course, the original semi-sync patches came from the Google MySQL patches that you can still access. And that is also where semi-sync originated from. MySQL replication took a great set of improvements when 5.6 came out. We ended up seeing things like global transaction ID. And I think global transaction ID is one of the most important changes that we end up seeing in MySQL 5.6 because you see that each and every transaction gets a unique identifier, and you turn this on via GTID mode or enforce GTID consistency. Generally speaking, you have the possibility to identify each and every transaction when it is committed on the originating server and as it is applied to slaves. So this is a big deal. There's also the server UUID, which basically tells you that there's a unique identifier for the server. You can ignore on the master server IDs. You can filter in replication. There's also per schema multi-threaded slave. So that's per database multi-threaded slave. The group comment in the binary log, very important. So you finally can turn on sync bin log equals 1. It will be flush log or transaction equals 1. The binary log checksums. So when it receives event that is corrupt, a slave receives an event that is corrupt due to maybe a network bit flip or something, it stops replication immediately. Crash save bin log and relay log as well. Time delayed replication, which means you can have a replica that is set behind in time by say 2 hours. So if you're doing these databases where you, applications where you do production pushes and something breaks, you can always go to a time delayed replica if need be. And this is very handy. Time delayed replication is still not released in MariaDB yet. It's one of those features that does not get ported. That is coming only in MariaDB 10.2. And the parallel replication is available on a per database basis as well. So again, you can speed up replication in a parallel format. It's since we're on the topic of what's not in MariaDB, I guess the server UID is also not something you will see inside of MariaDB. Now, a very cool replication feature that you get inside of MariaDB server as well as Percona server 5, 6, and greater is start transaction with consistent snapshot. The announcement basically makes the binary log positions consistent with MariaDB transaction snapshots. Feature is very useful to obtain logical backups with correct positions without running flush tables with read log like you have to do in MySQL. The binary log position can be obtained by two newly implemented status variables, the binlog snapshot file and the binlog snapshot position. So after you start a transaction using start transaction with consistent snapshot, these two variables will provide you with the binlog position corresponding to the state of the database of the consistent snapshot to be taken. So irrespectively of what other transactions have been committed since the snapshot was taken, you can take this and then do MySQL dump single transaction master data and get a full non-blocking backup. And Percona server obviously made it even better by adding the session ID and also having this feature called backup locks that you can play with. So feature originated in MariaDB server, was ported to Percona server in 5.6 and became better there. So, and it's also available in Percona server 5.7. So it's a highly recommended feature for you to take a look at if you've been running flush tables with read lock when you wanted to make consistent backups. Multi-source replication. The first ever MySQL that kind of had multi-source replication was Tungsten Replicator. And then after that, it became MariaDB 10.0 because it was contributed by Taobao into the MariaDB server. And then MySQL 5.7 came out with it as well. Naturally, there are syntax differences with both MySQL 5.7 and MariaDB 10. But the idea of multi-source is the same, where you can have GTID based master to multi-source, binary log based master to slave. This is of course good for things like real-time analytics, shard provisioning, as you would use with the Tumblr Jetpan solution, backups, and so forth. It's worth noting that in MySQL, it enables the replication slave to receive transactions from multiple sources simultaneously. Multi-source replication can, of course, be used to back up multiple slaves, merge table shards, consolidate data from multiple servers. It does not implement any conflict detection or resolution when applying the transactions, and those tasks are, of course, left to the application if required. GTIDs basically, of course, support multi-source replication. You can enable or disable them independently. MariaDB also supports this idea of replication domain, so you can have independent binary log streams so that queries in different domains can be run in parallel on the slave. Now, it's worth noting that in MySQL 5.6, you have to shut down all servers at once and enable GTID mode globally on both masters and slaves. In Percona Server 5.6, you could do this with what is known as the GTID step mode. So you didn't have to restart all your servers. You could just use the step mode to turn on replication. MySQL 5.7 allows you to turn on GTIDs without having to restart your entire topology. So this is now fixed, so you don't have to have the step mode anymore. And of course, MariaDB 10.0 and 10.1 have a different implementation of GTID in such that they just append GTIDs to the binary log. And these formats are incompatible between MariaDB and MySQL. So what this basically means is that if you have a MariaDB master and you attach a MySQL 5.7 slave to it, replication is unlikely to work. However, if you have a MySQL 5.7 master and you attach a MariaDB slave to it, replication to the slave should work unless there is a bug. And this is not obviously always tested, but it is well worth noting that if at all there is a bug, it does get fixed. So when you're playing around with global transaction IDs and replication, this is an important thing to note in the ecosystem of ours that we have. So why is GTID different? Because as I said, 5.6, GTID did not support multi-source replication. Also, you've got log slave updates equals 0 for efficiency. It's enabled by default in MariaDB, and you do it without restarting the topology. The good news is in 5.7, multi-source replication is also supported. Log slave updates equals 0 also supported, and you can turn it on without having to restart the topology. So there is now no good reason for there to be differences, but it's already down a path where there are differences. So now this is a user beware caveat emptor. Parallel replication is either in MariaDB run per table or in MySQL 5.6 and 5.7 run per database. But generally speaking, it should be as fast as the master. Your slave, that is. You can also detect non-conflicting row-based events by comparing primary keys and executing these in parallel. So parallel replication is definitely a good way to speed up replication. And there's some excellent research done by Jean-Francois from Booking.com about their use of parallel replication in testing and production as well, that you could reference. All in, of course, sometimes things do get out of sync. So sometimes people change information on the slave directly. Sometimes you use, still use my ISAM, which will give you deadlocks. Sometimes there's corruption on the master for whatever reason. Sometimes there's also bugs. So you have to be prepared for replication to be problematic from time to time. So you need to obviously monitor replication. One way to do that is to obviously use Percona toolkit. You have things like PT slave find, which will find slave information from the master, PT table checksum, which executes checksum queries on the master. So this is a consistency check, which is very useful. And then if it finds that there is inconsistency, you can use something like PT table sync to synchronize the table data efficiently as well. But of course, this also changes data. So make sure backups are important, obviously, and make sure you can restore from those backups. I think many of you must have read the news last week where GitLab had 5 backup methods or something, and none of them could actually restore, and it was a kind of a nightmare. And they were pasting their change logs and what they were doing to fix things, and the incident report was live on Google Docs, and it was a really sad moment for them. There is also another very cool thing that one could try is PMM, or Persona Monitoring and Management. We've built this tool with query analytics with significantly improved spark lines. It's got a metrics monitor. It's fully built on open source software, so we make use of things like Prometheus, Grafana, Console, Orchestrator, and so on. Basically, because we want to stand the shoulders of giants. It's very easy for you to deploy. We have a demo available for you to take a look at. So replication delays, you can see here visually what has gone wrong. Orchestrator, so if you go to pmmdemo.persona.com/orchestrator, you are also able to manage topologies with ease. So PMM is another very interesting tool that we've been developing at Persona and think is a very good way for you to take a look at your application topologies and improve your high availability. There's also another very interesting thing to note is that because distributions are shipping MySQL binlog, you may occasionally have MySQL binlog from MariaDB when you try to play with your MySQL servers, and you will see errors like found invalid event in binary log. That's because MySQL binlog in MariaDB obviously cannot read MySQL binlog in MySQL because they've changed. And also the streaming binlog backup server is not available in MariaDB 10 or 10.1, and it's only available in 10.2. So watch out for MariaDB server 10.2 for streaming binlog backup server. But all of this does affect your HA scope, so beware if you're happening to be mixing tools by accident. So another one of those things was the idea of slave prefetching. And there are tools like Replication Booster, Tungsten also had slave prefetch, and then Persona Server 5.6 and MariaDB 10.1 and one is on this thing is called InnoDB fake changes, where you speed up by having prefetch threads warm the server, replace statements, and then roll it back at commit. So you read rows for insert, updates, and deletes, but then you don't update them because that's why it's called fake changes, right? And this rollback is extremely fast because there's nothing to do, and it supports only DML. But I did say paradigms change. And in Persona Server 5.7, we replaced all that because you could use intra-schema parallel replication. So we removed the feature from ExtraDB. So no more fake changes. And we believe that MariaDB Server 10.2 will also have this feature removed because it's unlikely they would like to maintain the InnoDB fake changes. So paradigms do change. We come up with solutions that we're willing to throw away if there's a better solution available for you out there today. Tungsten Replicator, a great piece of kit, generally open source, was once independent by Continuant, then owned by VMware, then spun out again. And this replaces the MySQL replication layer with what is known as a transactional history log. So MySQL writes the bin log, Tungsten will read it, and will have its own replication protocol. It was the first to have a GTIDs. I think one of the interesting things it does is heterogeneous replication. And in today's world where a lot of these services are now based inside of MySQL, why do you need Tungsten? And one of them could be the open source MySQL to Oracle replication, or Oracle to MySQL replication, so to speak. Even Oracle to Oracle, right up to Oracle 12 before they remove change data capture in the server, is another feature that's available with Tungsten. Data loading into Hadoop and so forth. So there are still a bunch of use cases for it. The open source version, obviously, I'm referring to. Then there's Galera Cluster. Been around now for what, some 7 years. Works with transactional storage engine, and I should say InnoDB only, generally speaking. It has a quorum algorithm, minimum of 3 nodes. It works with optimistic concurrency control, so transactions are done locally on the node until commit time, then applied across all nodes, at which point there may be a reason for it to roll back and so forth. So there are retry auto commits available. In Persona Server ExtraDB Cluster 5.7, we have integrated it completely. In MariaDB Server 10.1, we have there is also the option, as in it's been integrated into MariaDB Server 10.1, so it's no separate download. The alternative to this from Oracle is what is known as a group replication. Well worth for you to check out as well. And this, of course, is the true multi-master active-active solution. Minimum 3 nodes required, automatic node provisioning, and so forth. As I said, Codeship attempts to make around maybe 3 releases a year. This has been reduced. They've just released the upstream release with 5.7. PXE, of course, is also up to 5.7, and MariaDB is basically 5.5 and up to 10.1 integrated. So you've again got different distributions available with different feature sets, and we've seen multiple users like OpenStack recommends Galera cluster, Mercado Libre, PagerDuty, AVG, and so forth. The Kona XDB cluster 5.7 is what we obviously would recommend because it's done by engineering within Percona. You have obviously got load balancing with Proxy SQL, and we've bundled Proxy SQL with XtraDB cluster. So not only do we bundle it, it's also allow you to configure it. We've also integrated it well with Percona monitoring and management. So we don't bundle it, but if you download PMM, you can get things that allow you to speak from Proxy SQL to PMM and so forth. And of course, you get the benefits of the full MySQL 5.7 feature set, which is something you don't quite get with MariaDB 10.1, for example. So PXE 5.7 is something you definitely should take a look at. And I think the fact that we are putting our stamp of approval at Percona on it, and engineering is being done in-house, this is a release to take a close look at. Group replication, it's based on a variant of the Paxos protocol called Menkes, and supports multiple leaders. It's a fully secure replication, again, so update everywhere, self-healing, lots of elasticity, redundancy, very, very typical for cloud use cases. And it also supports something known as a single primary mode, which means that it also goes back to this whole master with multiple nodes behind it. You can use SSL, it is elastic over TCP, and the big push is what is known as MySQL MDB cluster. So you combine group replication, you combine MySQL router, and you have the combination of MySQL SH, which you get in 5.7, and the X protocol, and you have easy out-of-the-box replication with InnoDB set up in typically less than 5 minutes. And there's a great video of this on YouTube as well. Then there's an NDB cluster, where you have 3 types of nodes, a SQL node, a data node, and a management node, and you need a minimum of 5 nodes. That's 1 management, 2 data, 2 SQL. And this is probably one of the first NoSQL databases out there, because in 2004 it didn't have an interface to the MySQL. You had the NDB API. It is different to InnoDB, but it does support lots of cool things like it's very high performant. It does online repartitioning. It's always on, and is typically very common in the telco space, but not very common in the web and enterprise space because it's not InnoDB. So quick summary of replication performance is that SANs obviously have latency and overhead. DRBD, you're always paying for performance penalty. I think generally speaking, replication when implemented correctly has no performance penalty. Semi-sync of course is poorer on a WAN compared to async, but semi-sync will guarantee you no transaction losses. And Galera NDB, of course, you get read-write, scale-out, and more performance. Then you think about how you handle failure. Do you poll? Do you monitor? Do you have alerts? Do you then have to decide what to do about it? Do you direct requests to spare nodes or to another data center? Always think about data integrity. You have to ensure that there's only one master at all times, so there's no split brain scenario. So you have to make sure that one node is completely gone, and you definitely don't want cold standbys. Good news, of course, is that there are frameworks to handle replication failures. MMM, which we have already said, do not use this. Cluster control by several lines. It's not open source. Orchestrator, MHA, Percona Replication Manager, Tungsten, MySQL 5.6 onwards inside MySQL utilities is MySQL failover and replication admin, as well as the MariaDB Replication Manager. If you can't use something like MHA because it doesn't understand MariaDB GTIDs, you can use MariaDB Replication Manager because it understands MariaDB GTIDs, but you can't use that, contrast to MySQL. So again, the server you use does play a role. Now, as I said, with PMM, we did include orchestrator, and we like orchestrator because it reads replication topologies, keeps states, has continuous polling. It's written in Go. You can modify your topology via a GUI or via an API. It's Apache 2 licensed. It's very well documented. Used at multiple places. Developed at Outbrain, then Booking, then GitHub. You can visualize replication problems. You can review, and kill long-running queries. It's an excellent piece of kit. And if you go to pmmdemo.percona.com/orchestrator, you can take a look at it yourself now, or even get PMM via Docker and play with it. It's extremely useful piece of kit, and it's going to be building in automatic failover as well. I was looking at MHA for all of this inspiration. And then there's of course MHA, specialized solution for replication developed by Yoshinori Matsunobu. And it does automated and manual failover options. So automated is for automatic failover if you're using semi-sync, and manual failover if you want to do things like online schema changes and so forth. The idea behind it obviously is topology is one master, many slaves. So it compares bin log positions, but it also does handle GTID failover in later releases. Then there's of course Pacemaker. You use heartbeat coercing pacemaker resource agents. Percona does provide in PRM, the replication manager, the resource agents that have it. Definitely read the docs. And GTID based PRM of course only works with 5.6 GTID and 5.7 GTID. So this is again not a solution for MariaDB servers. Then there's obviously the load balancing for multi-master clusters, where you can you obviously need to even think about failover of the load balancer, because hey, the load balancer itself might fail. And what I did not put on the slide was MySQL router, because I think MySQL router is still fairly new. It will be interesting technology going forward, but at this very moment, I would say the most interesting thing is Proxy SQL. Anyhow, MySQL router routes between apps, backend MySQL servers, does failover, load balancing, pluggable architecture. Application connections obviously transparently routed based on load balancing policy. Distributes application connections in round-robin fashion. So it'll forward MySQL packets to backend server without inspecting or modifying them, so you get maximum throughput. Then there's also MaxScale, made by MariaDB. I would say this would be the first router after MySQL proxy that was released. It's level 7 proxy router, understands the MySQL protocol, so it's got pluggable architecture, constantly monitors state of database nodes. It does query level analysis. It does schema-based sharding. It also has a Kafka backend that Percona wrote that you can see. But MaxScale after 1.4 becomes less interesting because it has a new licensing methodology called the business source license. So it is not open source software that you can just use. And the business source license limits you, that says if you have 3 servers, which is basically the minimum Galera clusters you're required to pay for those 3 servers behind the MaxScale. So this is now not a solution that we would recommend if you're looking at MaxScale 2.0. The solution we obviously would recommend is Proxy SQL. Where its largest deployment spells several hundred proxies with several hundred servers behind those proxies. It's a high-performance MySQL proxy with a GPL license. Performance is of course a priority, and they do lots and lots of benchmarks against Proxy SQL and other nodes. And if you go to proxysql.com/compare, you can actually see how it compares to other proxies out there. It obviously also does query writing. It can handle firewalls and so forth. One of the cool things I like about it is that you can actually change configuration at runtime. You don't have to restart Proxy SQL. So this is truly a proxy made by DBAs for DBAs. There are also the JDBC PHP drivers. Some of these drivers basically can handle failure as well. It's of course a layer less of network components, because these drivers are fully aware of MySQL transaction states and errors as well. So JDBC PHP, not too bad options for you to take a look at. Now, is clustering a solution or part of the problem? A one-time Percona employee and now founder of Vivid Cortex, Baron Schwartz, wrote a white paper, which we have on the Percona website, Causes of Downtime in Production MySQL Servers. Number 1 cause, human error. Number 2 cause, SAN. So do you understand? I think no. People should keep, aim to keep it simple. Use solutions like Percona HTTP cluster powered by Galera technology. Use regular Percona server for MySQL with replication and tools like Orchestrator, MHA, and so forth. And of course, if you're InnoDB based, obviously you know the workarounds for InnoDB, which make InnoDB solutions way more popular than, say, NDB solutions. So it scraps out MySQL cluster, obviously. So replication types out there. You have to think about competence choices as well. When it comes to replication, you basically ping the MySQL DBA, which presumably many of you are. If you are in a large organization and you are going to start using something like DRBD, when there's a failure, you're going to also ping the Linux admin, not just you, but also the Linux admin. If you get a SAN, somehow you get a domain controller. When it comes to operations as well, DRBD obviously gives you longer failover. Replication is the shortest failover, especially when now you have GTID. It really, really makes a difference. I highly recommend that you run with GTID. And when it comes to performance, SAN obviously is higher latency than local disk. DRBD also higher latency, but replication has very little overhead and redundancy as well. Shared disk is again your single point of failure, but a shared nothing architecture it makes it fairly redundant. So again, replication is definitely quite good. Now, earlier we talked about different types of replication, right? Statement-based being the default for a very long time, row-based replication being the default in 5.7. Row-based obviously is deterministic, whereas statement-based can be considered to be dangerous because you can be applying statements and they may not be correct. GTID now is obviously very easy to set up failover with complex topologies, and then people will probably want, is async good? Async replication will give you data loss in a failover. Fully synchronous, of course, is the best, but we're all about trade-offs. That's why semi-synchronous gives you no data loss and the best performance you can possibly get. But fully sync may be even good for you, but you need to be able to know that as you grow your nodes, you may get longer commit times. And of course, multi-threaded slaves also provide scalability. So you have to use modern technology. So MySQL 5.6 and greater will help tremendously. So for me, I like to always say simpler is better. Replication is much better than DRBD. It's much better than SAN. You definitely want to ensure you have no data loss, reduced latency. GTID will give you operational usability. And Galera generally provides a lot of this with good performance as well as stability. So, Percona HTTP Cluster 5.7 could be a choice for you if you have the ability to play around with the application. MySQL application is generally amazing if you know it and monitor it well enough. And I did speak about how you would be monitoring it. So again, some Percona toolkit of Percona monitoring and management. Large websites, so your Alexa top 20 that are powered by MySQL run just fine with semi-synchronous plus tooling for automated failover. Galera cluster is, of course, the current choice for fully synchronous replication, and we totally push it with Percona HTTP cluster 5.7. And of course, don't forget the load balancer, right? You need a load balancer. And in my opinion, the only open source choices today that you really want to look at are Proxy SQL and possibly MySQL router. But you definitely want to not be using any software that claims to be open source that isn't. And at Percona, if it wasn't already obvious by the fact that we're running a webinar, is that we really do care about high availability. So our 5.7 comes built in, bundled with Proxy SQL, and we also have good stuff for PMM to take a look at for you to read PXE data as well as Proxy SQL data. Percona monitoring and management coming with Orchestrator, where we combine best of breed open source. Percona toolkit has been around for a very long time. It is the staple toolkit for people who want to do stuff with MySQL servers generally. Percona server for MySQL 5.7, we believe is obviously one of the best choices out there for you to use as a server. but we also will support you in your usage of MySQL as well as MariaDB Server. And then there's of course Percona Extra Backup, very useful tool because not only does it allow you to run backups, you can also test your restores and so forth. And I guess with that, I'd like to say thank you for listening, and I'm open now to some Q&A for the next, I guess, is it 5 minutes or something? Jordan.
Yes, hi, can you all hear me? So yeah, if y'all have any questions, please ask them below. Yeah, we have about 5 minutes for Colin to go through them. There are a few there right now, Colin. If you want to go ahead and go through them and answer them.
I would, but I can't see the questions.
Oh, okay. Okay, perfect. Okay, so the first question is how to resolve table level locking in MySQL.
How to resolve table level locking? Are you using um, are you using MyXAM?
That's Devendra. Let me see. Devendra, if you could answer in the questions, that'd be great. If not, we'll go on to the next question.
Yeah, or we can also take it offline.
Yes. So question number two is how does MySQL fa- Fabric fit HA?
Yes, very good question. So Fabric, I didn't talk about Fabric much because we don't see a huge amount of updates to Fabric. Fabric is meant to basically look at large MySQL farms of servers, and it was meant to also be useful for OpenStack. But we believe now that most of the development is actually going towards router as opposed to Fabric. So, which is again why it is not actually mentioned. But Fabric is still around, and Router does have Fabric integration via even a Fabric cache. But we still think that more or less you will end up focusing on Router going forward as opposed to MySQL Fabric as a solution. And that's one of the other reasons why I didn't recommend the MySQL High Availability book because it does talk a little bit about MySQL Fabric, which is included in MySQL utilities, but we do not think that it's going to be pushed much more forward going forward.
Okay, great. And I'll go through one more from David Wilson. It says, can you talk more about random host selection with Percona ExtraDB and what is recommended or discouraged? And he says he has a 3 node cluster, and he wants to know, are we limiting throughout by not using random host selection?
Are we what out?
Limiting out by not using random host selection.
Okay, I think this is something that you may want to clarify again offline via maybe
Limit,
email.
he says. Okay, so I'll go to the next one. The next question is, how would you maintain HA during MySQL upgrade where the bin log format changes or some other backwards incompatible change to the replication mechanism?
How would we do upgrades? Well, so the bonus of doing an upgrade, I guess, if you happen to say be using 5.6 and you're still on statement-based replication, you upgrade to 5.7, your my.cnf will respect the fact that you're still doing statement-based replication. Do you want to then swap it out from statement-based to say row-based replication? You can dynamically change this at runtime to say that you are now going to upgrade going forward to row-based replication, and this should be of no problem to you going forward. So I wouldn't consider this a huge problem when it comes to upgrades, I guess.
Okay, great. And I'll do one more because we have quite a few. So you guys, we will post all the answers to these on our blog. And someone also asked if the recording will be available, and yes, it will be, and we will email it to everyone who signed up for this. So it will be available. And then, so the last question I'll go over is from Park Woo, and he says, "Does Percona 5.6 server master support MySQL 5.6 slave replication?"
Yes, so the question being, does Percona Server 5.6 support MySQL? Yes, Percona Server is a drop-in replacement to MySQL. So Percona Server can always be a master or a slave of MySQL. The only problems you may encounter is when you're using MariaDB Server, where it should be able to be a slave, but never a master to MySQL. Uh, yeah, so Percona Server, full drop-in replacement to MySQL. So do not worry about using it um, at all.
Okay, great. Thanks, Colin. And to everyone else, if we did not get to your question, we will answer them on the blog. So we will get to all of them. And other than that, the recording will be emailed to you in 48 hours. And I hope you guys enjoy the rest of your day. Thank you, Colin.
Thank you.
Thank you.